Again, welcome back to Caculus class. This lectures cover the chain rule. In this lecture, we shall go through examples of solving trigonometry and exponential functions using the chain rule. That's finding the derivative. So our main objective is to find the derivative of trigonometry and also exponential function using the chain rule. So our first example is we should find the derivative of f at theta equal to cos theta square. Now we can say this is a composite function. So here we need to find the derivative of cos theta square, which will give us minus sine theta square. Then we have to find the derivative of theta square, which will give us 2 theta using the power rule. So our answer here will be again, derivative of cos theta square will give us minus sine theta square times derivative of theta square will give us 2 theta. So our final solution will be minus 2 theta sine theta square. Now let's look at the second example. Find the derivative of cos squared theta. Now cos squared theta is the same as saying cos theta all square. So this is again composite function. We have to use the power rule to find the derivative of cos theta square. Then we multiply it by the derivative of cos theta. So derivative of cos theta square will give us 2 cos theta 2 minus 1. So the exponent will be 1. So it will give us 2 cos theta to the power 1. Then the derivative of cos theta will give us minus sine theta. So our final solution will be minus 2 sine theta cos theta. Now we know in trigonometry, 2 sine theta cos theta will give us sine 2 theta. Now let's look at the third example. The third example is exponential function. So we know y equal to 5 to the power square root of x. This is exponential function because the exponent is a variable. So first we need to find the derivative of 5 to the power square root of x, which will give us 5 to the power square root of x times natural log 5. Then multiply by the derivative of square root of x. Now, square root of x is s raised to the power half. So using the power rule, we get half times x to the power negative half, which is what we have here. So it will give us 1 over 2, which is the half. Now we change the negative half to positive half, so the s will be a denominator. And exponent half means it's a square root. So our final answer is 5 to the power square root of x, natural log 5 over 2 times square root of x. Let's look at the next example. So here we have to find the derivative of a function f at x, which is 4x plus 5 to the power 3, s squared minus 2s plus 5 to the power 4. Now, the reason why we want to solve this example, you can see that here we have 2 composite functions multiplied by each other. And also, it's multiplication, so we have to use the rule for product, or I'll say product rule or multiplication rule. If we can remember, multiplication rule said that, for example, derivative of 4x plus 5 to the power 3 times x squared minus 2s plus 5 to the power 4 plus derivative of s squared minus 2s plus 5 to the power 4 times 4s plus 5. At the same time, when we are looking for the derivative of 4s plus 5 to the power 3, we have to use the chain rule. When we find the derivative of x squared minus 2s plus 5, we also have to use the chain rule. But since these two terms are multiplied, we also have to use the product rule. So that's the solution here. Here, again, it doesn't matter. We can find the derivative of 4s plus 5 to the power 3 first, or s squared minus 2s plus 5 to the power 4 first. Here we decided we write down 4s plus 5 to the power 3 multiplied by the derivative of x squared minus 2s plus 5 to the power 4. So we use the power rule first. We get 4, which is the exponent here. S squared minus 2s plus 5. 4 minus 1 will give us 3. Then we have to find the derivative of s squared minus 2s plus 5 using the chain rule. So that will give us 2x minus 2. Plus, this is a product rule. So plus, we find the derivative of x squared minus 2s plus 5. So now we have to use the derivative of 4s plus 5 to the power 3, which will give us 3 times 4s plus 5 to the power 2, which is 3 minus 1, times the derivative of 4s plus 5 using the chain rule, which will give us, again, x. Excuse me. So let's go through the steps, which will give us 4. So let's go through the steps. So we write down s squared minus 2s plus 5 to the power 4 times the power root again, 3 times 4s plus 5 to the power 2. Then the root of 4s plus 5 will give us 4 plus 0, which will be 4. So now we just have to simplify the expression. So here we write 4s plus 5 to the power 2, s squared minus 2s plus 5 to the power 3. Then we combine the terms here to do our multiplication. At the end, we get 4s plus 5 to the power 2 times s squared minus 2s plus 5 to the power 3 times 11s squared minus 4s plus 5. Again, we don't need to open all the exponents, so I think leaving it here is okay. Or around here, even we can say also it's okay, but if we like, we can again do some simplification, which we did. So let's go to the next question. The next question is a trigonometric function. The goal here is how to use the chain rule. That is our main goal. The rest of the simplification, again, we can do it in what I mean, like this question here, we can leave the answer somewhere around here if we want to. But again, it's good to combine the like terms. Possible we can do, since this is one exponent, we can multiply them, open the parentheses, combine. Okay, so now let's see our chain rule here. So find the derivative of s at t equal to 1 plus sine t divided by 1 plus cos t. So as we said, square root is the same as exponent of half. Now here we have to be careful. We have a quotient rule, which means we have to find the derivative of the down and the top, and the numerator times the denominator minus derivative of the denominator times the numerator, all divided by 1 plus and the denominator all square. This is when we are using the chain rule. So the first thing we need to do, we use the power rule first. So we get half times 1 plus sine t over 1 plus cos t. Half minus 1 will give us negative half. So that's what we have here first. Then now we have to find the derivative of the term inside, which is 1, excuse me, which is 1 plus sine t over 1 plus cos t. And that's the answer here, as we said. So it will be derivative at the top multiplied by the down minus derivative at the down multiplied by the top, or divided by the down square or the denominator square. So this is what we get. Derivative at the top, we have derivative of 1 is 0. Derivative of sine t is cos t times the denominator 1 plus cos t minus, let's do that down, derivative of 1 is 0 again, derivative of cos t will give us minus sine t times the denominator, which is 1 plus sine t. We can leave the answer like this, but it's good. We can simplify it, and our final solution will be this. Possible do cancellation, combine, or use the trigonometry formulas, identities to simplify it, to reduce the expression. So let's go to the next question, which is find the derivative of j at theta equal to tan square n theta. Here again, n theta, make it a composite function. Now we saw the previous example called square theta means the square affects everything. So the same thing here, tan square n theta means tan n theta all square. So first thing we do, we use the power rule again. Then we find the derivative of tan n theta. So using the power rule, we get 2, which exponent is 2. Tan n theta, 2 minus 1 will give us 1. Then we find the derivative of tan n theta. The derivative of tan n theta again will give us the sec square n theta times n using the chain rule. So finally, again, we have the 2 tan n theta here. The exponent 1, we just ignore it. Then here we have our sec square n theta, then n. Derivative n theta will give us n. And then we can just simplify or combine the terms together. So we get 2n tan n theta times sec square n theta. Now let's go to the next question, which is exponential function. But when we look at the top also, we have a trigonometric function. So to find the derivative of this, we need again to use the chain rule. And also we use the exponential rule also, exponential function rule also for derivative. So we know already the derivative of e to the power x is the same as e to the power x. So the derivative of e t times sine nt will give me e t times sine nt. Then I have to find the derivative of t sine nt. That make it the chain rule. So that's what we have here. So now when we look here, it's a t times sine nt. So we have a product rule here that we have to use. So this means we get t, derivative of sine 2t will give me cos 2t. So we get t times 2 cos 2t plus sine 2t, derivative of t will give me 1. So sine 2t times 1. Then we can combine the terms here. That will be our final solution. Then our last question is find the derivative of y equal to 2 divided by 1 plus e to the power negative x. So here we use our quotient concept rule here. So to find this derivative, first of all, the derivative of 2 is 0 times 1 plus e to the power negative x minus 2 times derivative of 1 plus e to the power negative s. And this will give us 0, and this will give us the derivative of negative x will give us negative 1. So that's why we have negative e to the power negative x. Then divided by the denominator or square. This is again quotient rule or square. Then we combine the term, and this is what we have. Now here we say at 0 and 1, here we are going to substitute, which means the value for x 0. So here we have 0 here, 0 here, and when we solve this problem, we get again half. So an equation of the tangent line is y minus 1 equal to half, which is here, x minus 0. If this is given to us, and they say we should find it, and the coordinate is given to us 0, s is 0, y is 1, the point. And they say we should find the equation of the tangent line with this point. So after we find the first derivative of the equation, we are going to use the formula y equal to y1, and the slope, again, the slope will be, as we said at the beginning of derivative, slope is always the value of the first derivative of a function. So the slope is half. The point for x is 0, so s minus 0. And we simplify it. That will be the solution here. So that will be the conclusion of these lectures. Again, if you have any question, you can send an email or when we meet in class. Thank you. Bye.